Hey there, CJ Math students. Welcome to classwork homework 7.9. So if you had difficulty with the homework and you wanted to review how we did some notes, or you were out and you needed to do this, this is the video for you. So it's problem solving with volume. The first couple of problems are simply problems with volume. So a reminder, the volume formula is always volume is equal to big B for the area of the base times height. That is not simply base, it's the area of the base. That means you're working with all of the space inside of the base shape. You're trying to find the area of this base shape and using the dimensions to find its area first. So here you're going to use 16 and 9, right? So if we've got 16 by 9, it's a rectangle, so we use the rectangle area formula, base times height. Base of 16, a height of 9. That gives us an area of 144. That means our base of our three-dimensional shape is 144. So volume is equal to 144. Now times the height of our shape, which is that dimension right there, 12 times 12. So our volume is equal to 1,728 inches cubed to the third power, right? Inches cubed. How many 1 by 1 by 1 inches square blocks could I fit in that shape, right? When we have a triangular prism, you'll notice again this is a triangle, right? We're going to again use the measurements of this. It's the same exact formula, V equals BH, but again the base is the area of the base shape. So area formula for a triangle, base times height divided by 2, or area is equal to 5 times 7 divided by 2. So your area of the base is 17.5. So you're going to say my base is worth 17.5. Now the height of this, or how far it's extended, is 16 feet. So times 16. So the volume of this shape is 280 feet cubed again. When we're talking about a problem like this, when we're related to the real world, we always want to break it down. What do I know? What do I need to know? Plan and work. Most of these problems, you're going to find me volume, but then you're going to have to do something else with it. So it says the neighborhood swimming pool is in the shape of a rectangular prism. The pool measures 30 feet in length, 18 feet in width, and has a depth of 4 feet. Right? There are your dimensions, right? But it also says if there are 7 gallons of water in a cubic foot, how many gallons of water are in the swimming pool? So let's write down everything we know. We got a rectangular prism, we got a length of 30 feet, a width of 18 feet, and a depth of 4 feet. Now let's write down what I need to know. The question asks us how many gallons of water to fill the pool. Alright, so now let's go ahead and plan and work. So you want to start by drawing a picture. To draw a three-dimensional rectangular prism, it's easy. You just draw a rectangle, draw another rectangle behind it, and then connect all the vertices like this. Hopefully, since yours is on graph paper, a little bit nicer than mine. Plug in your dimensions. It's a length of 30, it's a width of 18, and the depth, or how deep it is 4, also known as our height, right? Okay, so let's find our volume. V is equal to base height. Remember, base is the area formula for a rectangle. So area is equal to our base of 30 and our height of 18. Again, where did I get that? We're just looking at the base shape, this shape down here. That's the rectangle. We're just trying to find the area of that. We're using the dimensions of 30 and 18. All right, so area is equal to 540. So our volume is equal to 540. Now we need one more number times the height, right? Volume, you're always multiplying at least 3 numbers, 3 dimensions, right? So your volume is 2,160 feet cubed, all right? But you have not answered the question. The question asks for how many gallons of water we'll need to fill the pool. You go back in here, and remember it says 7 gallons of water are in 1 cubic feet. So if I have 1 cubic feet, I need 7 gallons. If I have 2 cubic feet, I need 14 gallons. If I have 3 cubic feet, I need 21 gallons. So if I have 2,160 cubic feet, to answer the question of how many gallons I need, you simply are going to take the volume of the pool, which is 2,160 feet cubed, and multiply it by 7, right? and that gives you 15,120 gallons of water, and that is your solution. So 15,120 gallons, GAL, of water to fill the pool. Okay. Question number 4. It says a refrigerator box is the shape of a rectangular prism. It is 78 inches tall, 48 inches wide, and 24 inches deep. How many cubic feet will the box hold? Notice they gave you stuff in inches, and then it asks you for an answer in feet. So what do we know? It is a rectangular prism. It's 78 inches tall, 48 inches wide, 24 inches deep, and this is important. 12 inches is equal to 1 foot. What do you need to know? You need to find out what is the volume of the refrigerator in feet. All right, very important thing. So first thing you want to do, draw your refrigerator as a rectangular prism. So draw kind of a vertical rectangle here, and then another vertical rectangle behind it. And then go ahead and connect your vertices. And now fill in your dimensions, right? So it is 78 inches tall. It is 24 inches deep. Like how far could I reach into the refrigerator? And it's 48 inches wide. Now, those are in inches, remember? We want to convert all of our measurements in inches to feet, right? So if this is 78 inches, I want to convert it to feet by dividing by 12. Dividing by 12 and dividing by 12, right? Doing so gives us our new dimensions. So this is 6.5 feet. This is 2 feet. And this is 4 feet. Okay, now we can figure out our volume. Our volume is equal to big B times H, big B being the area of our rectangular base. So that space, meaning we're using the dimensions not 48 and 24 anymore, but 4 and 2. So area is equal to base times height, not divided by 2 because it's not a triangle. Area is equal to 4 times 2. So area of our base is 8. So our volume is 8 times our height of 6.5. And this gives us a volume of 52 feet cubed. So our answer, 52 feet cubed, is the volume, or how many cubic feet could fit in the refrigerator. All right. On the back side, you've got a problem like number 5 that's very similar to the problems that we've done on the front, where you're going to need to find volume, but then you're also going to need to do something else to it, so read the problem carefully. And then from 6 through 10, you're working with your original container here. That this juice company is saying, hey, should I sell it in the original container or should I sell it in the proposed container? Remember, this is a rectangular prism. So that's just going to be V equals BH, where B is your area of base times height. And this is a triangular prism, where this is going to be V, equals BH. But this time, your base is going to be the triangle formula, so BH divided by 2, right? If you can see your triangle at the bottom here, it's right here. And so you're going to use dimensions of 2 as your base and 3 as your height just for the triangle, and then 5 is going to be your overall height of your shape. So question 6, basically use both of those formulas to find me the volume of the original and the proposed. Question 7, if each cubic inch costs 12 cents, then how much will it cost to make the original container versus the proposed container? Basically, just take your volume answer that you get in 6 and for original and proposed and multiply it by 0.12 for each to see the cost. Question 8, you need the profit, right? Because it's talking about if it's sold for $3.28, how much profit does it make? The profit equation is your price minus your cost to make something is equal to profit. And they just want to know about the original container. And then question 9, again, is related to that profit equation. And then number 10, you're going to recommend which container the company should use. You obviously want to make the most money out of it, so you want to build the cheaper one. Okay? That's it. Call me if you have questions.